Imagine you're trying to describe how a person walks. You could just list where their foot is at random moments, but that's not walking, it's just a recorded of locations. Many current models are like that. They're great at the what, but terrible at the when. The authors propose to fix that by teaching the model to respect the clock and the sequence. It makes synthetic data that actually flows like a real human move. This is the core setup. It takes numbers and categories and lets a network guess the noise. It's like a chef who knows how much salt to use, but doesn't care what order ingredients go in the pan. For a static table, that works fine, but for a moving sensor, it treats every millisecond as if it has nothing to do with the one before it. We are starting here because it is efficient, but it lacks any sense of rhythm. Here is the new blueprint. We didn't throw out the old machine, we gave it a better memory. We've added context blocks that tell the model exactly what activity we're trying to mimic. Notice the adapters at the end? Those are convolutional filters. They act like a check to make sure the signal makes sense locally. It's like giving the chef a timer, so the motion looks like a wave, not just random spikes. How do they build this? They use 3 tricks. First, we tell the model where it is in the process. Second, we give it a label for the activity type. Third, we use a mask to handle gaps when sensors fail. Then we use these clever adapters. Instead of a giant slow brain, we use small fast filters that look at a few steps at a time. It's efficient, simple, and it keeps the data's natural beat. Model was tested on real data from people carrying phones. It's messy triaxial acceleration, meaning movement in 3 directions. Some activities, like walking, have tons of data. Others, like sitting, are quite rare. Machines learn better when things are balanced, so we use this lopsided data to see if our model can fill in the blanks without losing the truth of how a human actually moves through space. These grids show where the model gets confused. If the diagonal line is bright, the model is doing great. Look at the sitting and standing classes. The old model was guessing all over the place. Our new version nails it, matching the best traditional methods. Even for the tough stuff like going upstairs versus downstairs, we're keeping up with the pack while maintaining a much more realistic signal structure. What's the big idea? The research shows that you can take a model meant for static tables and teach it to understand time. By adding a few lightweight parts, we get synthetic data that doesn't just look right on a chart, but actually behaves like a real signal. It's about making sure the data itself is honest. This paves the way for better activity trackers without needing to follow millions of people around with sensors.